Good morning and welcome to our webinar. My name is Odette Hines, and I'll be your moderator for the webinar entitled Getting Started with Google TensorFlow on Spresense. Your presenters today will be Armagan Ibrahimi, who is a partner solutions engineer at Sony. She works at different divisions at Sony to bring innovations to developers and businesses to build scalable solutions. She has over 20 years of experience in the high-tech industry with a mixed background in hardware and software engineering. She has worked on chip-level verification on ASIC and FPGA all the way to the video player on Android and iOS devices. She supports Sony Spresense in North America. Our next presenter today will be Kamil Tomaszewski, who's an embedded engineer here at Sony. He's one of the major contributors to the Spresense technical support team. He has supported CircuitPython on Spresense and supports Spresense documentations, built demos, created tutorials, as well as interacting with customers and developers who might have technical questions or concerns on forums, webinars, or at all events. He supports Sony Spresense globally. Before we start today, I want to provide you with a few housekeeping rules. All participants are in listen-only mode. If you have a question during the webinar, please type them in the question section in your Zoom control panel, and I will ensure that they're answered at the end of the webinar. If we do not get to your questions today, we will send the answers to you a few days later. The on-demand version of the webinar will be available within the next few days, and we will ensure that that is sent to you as well. If you require a conversation or a demo, please ensure that you put that request in the question section of your Zoom control panel, and I will ensure that they're directed to the presenters at the end of the webinar. Now, without further ado, I'll pass it over to the lady of the hour. Armagan, you're up.
Hi, thank you so much, Odette. Hi, everybody. Thank you so much for joining our webinar. My name is Armagan Ibrahimi, and I will be presenting Sony Spresense programming with TensorFlow. So first, let's see what's going to be covered in this presentation. The agenda for today is brief introduction of Sony microcontroller, Spresense. We talk about TinyML and Spresense as a device for TinyML. And then I have two sections here for this programming with TensorFlow. The first section is examples that has already been built, and the model is built on TensorFlow. And the second one, we teach you how you can build your own model using Spresense. At the end, some news and updates that I will share with you that you may be interested. So let's first focus on the Spresense microcontroller, just in case that you haven't used it. So what you need to know about the Spresense is some highlight features and capability. And if you look at my slide, I have two sections. The right section is giving you some kind of overview of capabilities and how you can access a Spresense board. And then on the right hand side, you have the highlights that Spresense can provide on the board. So let's look at the highlights first. So Spresense, the main thing that Spresense is good at is Spresense is very power efficient. So it's low power. You can target some applications that you put your device somewhere in the middle of nowhere and you don't have access to power. So this is the first let's say, capability of Spresense. And then we have high resolution audio on Spresense. High resolution audio, it means that you can listen to a machine in a factory and detect some abnormalities. So this is another capability that you can take advantage of. And also the GPS is already integrated on Spresense. You don't need any antenna. And we almost covered the globe. So we have a GPS in the US, we have QZSS in Japan, and then others that for different regions of the world. Having said that, let's now look at the little table that I have on the left-hand side. Spresense is using 6 ARM cores and has 156 megahertz of clock. It depends what kind of you can add sensors and connectivity to Spresense. So you may need to use different digital IOs. As you see in the list here, we have GPIO, we have SPI, we have I2C. So you can connect your sensor or connect your sensors here via these pins. Also, we have analog inputs that provide, which we have 6 channels, 3.3 volt. This is for when you add any sensor or connectivity to Spresense. And then we have audio access also, 8-channel digital and 4-channel analog. Also, you can get a stereo speaker output from the Spresense also. I told you about GNSS. Other things that is good to mention is the camera interface, which I'm going to show you. So the camera interface, you can slide the camera right in. We have an SD card that you can use for storage and access to I2S. This is a brief overview of Spresense. And now let's look at the components. Spresense kit has 3 components: Mainboard, extension board, and camera board. Let's look at the Mainboard first. So I have more details provided here. Mainboard has 2 chips on it, and each of them are in charge for different functionalities. For example, this one, which is CXT5602, is going to support the high resolution audio. Or if you look at the other one, I have the microphone interface support on this chip. Why this is important? At this point, we are providing the kit, but eventually, if you go large volume, you may get these 2 chips. And these 2 chips has been used in smart headphone for Sony Xperia before. So just for you to know. And then look at the extension board and camera board. You don't need to have these 2 unless you want to use it for your application, and it's going to make it a lot easier to do prototyping. Why? Because, for example, the camera, I told you that you can have the camera connected to the Mainboard. This is the place that you can slide in the camera connection, and then there you go. You have the camera connected. Extension board is providing different voltages. So it's like 3.3 and 5 volt. You can get that voltage from this board. And then we have access to microphone. This is for audio. We have a SD card access. And here you see that we have the possibility that you can put other Arduino shield factors, Arduino shield form factors here on the board. And also these are the audio out that you can get. So this package, this kit is going to help you to make development faster. And if you need to get these boards, our distributor is Framos. And you can look at the list of our distributors here. The main one is Framos, which is hosting this webinar. Now let's go to TinyML and Spresense. TinyML is as you can say from the name, is a tiny machine learning that is by Google. So what is TensorFlow Lite macro? So TinyML, TinyML is giving you the capability of doing modeling and machine learning on machine learning, but TensorFlow Lite macro is specifically for microcontrollers. Microcontrollers are not like a computer that you plug it in the wall. So microcontrollers, they have limited memory. So this kind of devices, if you can equip them with a capability that you can model and you can run ML on them, then you can, the whole package is going to provide you a smart device to target applications. So TensorFlow is nothing but providing machine learning capabilities in a very small size, as like few kilobytes on microcontrollers. We have partnered with Google, and Spresense is listed under the devices that supporting TensorFlow. If you go to this link, you can see our board that is supporting the TensorFlow. But as I mentioned, TensorFlow Lite Macro is targeting devices that are microcontrollers, and it's not it doesn't have very large memory. But what we expect from that is it has to be low power. But let's see why Spresense is a good device in combination with the TensorFlow. Spresense has powerful processors. It has 6 ARM cores. And then also, because of the 6 ARM cores, you can do a lot of edge computing. So edge computing means you don't need to send it to the cloud. So you're going to save some money, and at the same time, you can do all of your calculation and computation on the device. And also, Spresense is low battery, is power efficient. What does that mean? It means that the device can run for longer. Again, if you have a device that you don't need to plug it in the wall all the time, then you can leave it. It doesn't need human interaction, and then you can target some applications that is in the middle of a forest or in a farm. And also, if we go through these things, and then we look at the board capabilities, is the camera, and then high resolution audio, and then integrated GPS. So what TensorFlow does, it gives you a tiny or small machine learning that you can put on your device. Spresense, it gives you the low powerful processors and all this edge computing that you can do. So you can target your variety of applications for Spresense and with TensorFlow. So now let's go and start with doing running some examples. This section will cover 3 examples. One is the hello world, then is audio, and is camera. Hello world is, let me just go a little bit more. All of these examples, by the way, it has been modeled on TensorFlow. So this is the part that you get to run each of these on Spresense. But what you get out of it, first of all, you make sure you can run TensorFlow, and then also you make sure your setup is okay. And then, as I mentioned, we have audio and camera. With the examples that you see here, micro speech and person detection, you can try to access the audio and camera on the Spresense and test it with these 2 examples. So what happens here, I told you this is all built on TensorFlow. Let's look at this picture. We have the hello world, all these 3 examples, as you see in the gray, they are built on top of the TensorFlow library. Okay, and then if you look at the light color or yellow color, you see Spresense here. Spresense is a real-time operating system, is Nutex. And now we are working with audio, so we need to provide the Spresense audio component and camera. Nutshell is just a command line provided by Nutex, then you can run these examples. TF example means when you run these examples, it gets wrapped into this TF example, and then you can use this to run on Nutshell. Everything here, so is we are using the same build as provided by TensorFlow Lite Macro here. So this is just, we are running examples from TensorFlow, okay? So now let's look at the hardware. What do we need? For the first example, you just need the mainboard. For the second one is the speech. So you need to get a microphone because the first one, so you just need the mainboard, and this one you need to connect a microphone. I have provided a link for how you can connect the analog microphone here. And then the last one is the camera. So this is how you connect the camera, and you just need the mainboard and camera board. Now you know the hardware. Let's look at the some directories where you can get this file. This is a straightforward. All of the examples, it goes to externals, and then under TensorFlow for hello world and micro speech and person detection, these are the folders that you can access this. And then how to, the command is TF example. As I said, so each TensorFlow Lite macro example is wrapped into a command called TF example so that it can be run as a command in Nutshell. Okay, so the nutshell is nothing but the nuttext command used by Spresense SDK. So just keep that in mind. Next step is we have to start building, right? We know what components we need and we know where the files are. We do the build in two steps. The first one is configuration, and the second one is execution, right? So for the configuration, we have to change. I say here change directory to SDK, because when you clone Spresense SDK, you get a folder called Spresense, and then you have subfolders in that. First thing first, you have to switch to SDK directory to be able to run commands. For all of the development, that's what we do. And then you start doing the configuration, and I'll show you the commands for this. And for the execution, we generate the file, nottext.spk, and we need to flash that on the board, and then we run the example. So for Minicom is just to show the output, and then we can check the results. I have provided something here that you may be interested. If you haven't seen or haven't been on our Run Spresense with Nottext webinar, you can find the link here. In just half an hour, you learn how to use Nottext on Spresense, and all of the supporting materials and links are available there. And this is another link for just when you want to start with Spresense for different platforms. This is the link for that. But this is all. And then for from the version 2.1, we support TensorFlow. So we are done with the build. Let's look at the commands. We are going through the different steps. So we have to switch to Spresense SDK, as I mentioned before, and then we run some kind of setup. Then you can use tab on the command line. This is for that. And now we need to do the configuration. You use the config.py under tools to configure for each example. You have to pass this parameter here, default config name, and I provided a table here which it tells you how you can access each of these. So if you want to write, if you want to do hello world, then you need to provide this default config name here in the command. There is an example at the end of this page that is targeting. So we are using the micro speech. So as you see, we have the config.py, and then we have under tool, and then we are passing this default config name for micro speech here. So this is how you do the configuration, for example. And now let's look at the execution. For execution, we run make. When you run make, you generate this nottext.spk. This is always what you get out of make. And when you have this nottext SPK, you need to flash your board. To flash your board, you use this command, and this dev tty USB. This is your USB connection, and this is the baud rate, and this is your SPK that you just use the make to generate it. And then you access to Minicom. So you need to run the examples. To access the Minicom, you have USB connection to your board. And if you want to see the output, you need to connect to some kind of USB terminal or output. It could be Minicom, it could be a screen. Whatever you feel comfortable and you work with is fine. Here I'm using Minicom. And then when you go to Minicom, you see the nutshell command. And then you can write TF example here to run your example. And so now we want to look at the output. Each example has a different output. By the way, I don't know if I mentioned. So hello world is a sign function. So you have different values. So you have 0, you get 0 and 1. And so that's it's going to show you those values. So you see here. And then for the micro speech, it has a microphone, so it listens to you and is listening. And if you say yes or no, you see it here. And if it's something other than yes or no, it's going to say unknown. Okay. Now for the last example, we have the detection, person detection. This is for the face. So if the camera is pointed at the person, then you're going to get a higher score versus is not a face or is far away. Okay, so these are the output of these examples. For this section is done, so we ran some examples that it was run some examples that it was built on TensorFlow. Now let's learn how we can create our own application for TensorFlow application with Spresense SDK. So in this section, we just provided this capability because we basically build a wrapper to make it easier for developers to develop with Spresense and TensorFlow. So the library that we have to support TensorFlow is TFLM runtime. We called it this. And this is supporting the TensorFlow libraries. And then you can do recognition using the deep neural network, and you can train your model. Here, I show you a sample application. And when we go through this application, you learn how you can build your model and use Spresense directly for TensorFlow. This example is nothing but a handwritten number recognition. You know how you have, imagine you have a bunch of pictures of numbers, but they are handwritten. We have different pictures, and then you can look at each of them and recognize if this is a 9, if this is a 0, or so on. So for that, we have to go through two steps. One is the train your own TensorFlow model, and then you have to convert to TensorFlow Lite model. Because again, this is a microcontroller. We need to quantize it. We need to make it smaller to be able to put it on our device. Before I go to example, I want to show you something that is happening in the background. We have DNNRT, which is our deep neural network runtime library to support AI on Spresense. And if you look at the step-by-step or sequence of instructions when you have on Spresense, when you start model, and then when you run it on Spresense, this is what you have. Well, this is what you follow. So you have your application, then you do initialization, and then you go through this step. This is a loop, for example, for forward or runtime output buffer and all of this. And we have provided this library, TFLM runtime, which is, it means that we put a wrapper around TensorFlow libraries to make it easy for our developer to develop with Spresense. So this is something that Camille has done, and to make it easier for developers to use Spresense. This is what is happening in the background. And if you had experience with Spresense with AI, then you're just follow the same thing, do the same thing. Now, let's see, we have four steps to build our own model, our own application for TensorFlow on Spresense with the Spresense SDK. These are the 4 steps. First, we need to train your model, and then you need to convert it to TensorFlow Lite model. Then you build and do operation check. Please note that if you can go through all of this step, or for example, you can bring a model if you don't want to train your own model. So, but eventually when you build it and then at the end you check the result, these are, you can see if it's working and check the results. So now let's look at this example. So this what we need to do. We have a data set that is using is used for classification and training the TensorFlow model. And what we are using here is actually MNIST database of handwritten images. And so for TensorFlow, you can download and import the MNIST database directly from an API. We have a Python code here. This is just some help. So, but you can write your own. But this is a Python code just to train your model. And what this Python code gets is an image of the size is 28 by 28, and it's going to output an array of 10 because we are doing digit recognition. So we have 0 to 9, so 10 array. So we have 10, we have index 0 to 9 to recognize different digits. And I'm not going to go through the steps like how you do the training, like how you have your data set and then you do the training and going through the steps to build your model. If you need to just get an idea, I had a kind of 1 hour webinar for AI and Spresense, and you can go and listen to that. It's going to tell you all the basics for how you train your model, how to use Spresense, and a lot of examples with DNN-RT. So now let's focus on here. We have a Python code to train our model. This is available in our website. Actually, I have provided a link at the end. And when you train your model, next step is the conversion. So because as we know, the model that you build, it has to be quantized. You have to make it smaller to be able to deploy it on devices, any device like out there. So this is the part that this is again a very short code to transfer and convert your model. And then after you have that, then you need to go through the build procedure. For the build procedure, it's just you need to go to SDK and run the commands. You need to, we have here the config.py. If you notice that here, the example is TFLM RT Linux. So, and then you do make, you generate the NotX SDK. And after you generate the NotX SDK, you need to flash the board. This is how you flash the board. So by here, then you are done with the build. You need to check the results. To check the results, you go to Minicom, and when you open the Minicom, you can run this command, TFLM RT Linux. But if you look at this command, you have the option of having skip the image normalization, or if you wanted to normalize it, you can do it. And then we have TF Lite and then PGM. So if you have your if you wanted to pad to TF Lite model, you can use it here. Or if you wanted to have the PGM image, you can add it here. In the next page, I have an example of running this. The first or top part, it shows you how you can run this command. And this is the path to the model. So that you have the model here. But this one is not doing any, so it's not, it doesn't have the path to model. It's just doing the default command that we have for TFLM RT. So it's not passing any, it doesn't do any. If you go to the previous page, see, we are not passing any option. So we skip the normalization. We are not passing any model or PGM. So that's the default one. And then when you look at it, what I said, we have index 0 to 9. And then each of them has a probability of, when you show a picture, to tell you this is 0 or this is 1. Or as you see in this example, is recognizing 0 and it has the highest probability. So this is how you can build your model via this example. And now you know how both ways, if you want to bring an example from TensorFlow, that it has been modeled on TensorFlow, how to run it. And now with this example, you know how to use Spresense directly to model, to build your own application on Spresense SDK for TensorFlow. So this is all that I had for this presentation. Let's go to last section of my presentation, which is the news and updates. The upcoming news is we have the LTE Cat-M extension board coming up, and we have a HDR camera board, which is going to be released hopefully early 2022. And the other exciting news is Spresense is going to space November 7. This is by JAXA from JAXA, right? So is the space agency in Japan. Why is important to say this here? Because if Spresense is going to the space, it has to qualify and it has to go through a lot of testing, regressive testing. And we know that for some of the applications that we are targeting for IoT, the environment can be harsh, very cold, very hot, or other conditions. But here with this, we can at least say Spresense can be suitable for those kind of applications. The other exciting news is that we have our partner is Edge Impulse. You learn here how to use TensorFlow on Spresense and running the examples. As you know, Spresense, the kit is it's very easy to do prototyping. What if you get the AI part from Edge Impulse? Then in few minutes, you can build your own application, a smart application with Edge Impulse. I have provided a link here that you can start with Spresense and Edge Impulse to target your AI application. Is a lot easier. You don't need to be expert in data science or AI. So you get a lot of help and benefit from this tool. And at the end, there are some links that I would like to share with you. So Spresense website, of course, we get a lot of good feedback on our documentation. We cover everything. And all the webinars that we have is very short, maybe 30 minutes, but you learn how to start with that specific topic, and we provide all of the links to our document. Then you can easily navigate to our document. Sorry. And then please follow us on Twitter, Sony DevWorld. If you have any exciting application for POC, if you are a small business that you want to work on a new application and you need our help and support, please make sure you contact us. This is the link. So go to inquiries on Spresense website. We provide support for our developers on our forum. We have a YouTube channel that provides all of these webinars, and our partners for our distributors. The main one is Framos here, so you can access our web shop on this link. And this is how you can start with Edge Impulse and Spresense to build your AI application. Thank you so much for listening in. And now I think we are ready for the question. I can keep this one or just
that one is fine.
Okay,
so
then they can look at the links and stuff. Yes.
Yeah. So thank you so much, Armagan, and thank you for all who've stayed with us throughout the webinar. If you have not submitted your questions yet, I could see some coming in right now. Please do so by typing them into the question section on your Zoom platform, and we'll get to them. As I said, we do have some that we can get to today. So let's start with the first question. It says, does Spresense support or going to support other tiny ML platforms other than TFLM? I will pass this to Camille.
Yes, so we are also supporting Nabla. So we can also do TinyML using the Nabla. And that's all for now. Do you have maybe if you could, for example, say what kind of TinyML platforms do you have in mind that can be supported as well, so we can consider also to add the support for other. So maybe if you have a time to write this here, or if you have a time to write on the forum.
Okay, perfect. So if you want to add additional information, as Camille says, please add it here or on the forum, and he will get back to you regarding that. I actually have another one that was directed at you specifically, Camille. It says, do you try to run TensorFlow on one of the subcores? Example, on the main, you get the picture, use share memory to do the inference on a subcore.
Yes, so I didn't try it yet, but for sure it's possible, but the software is not ready. Right now, I was preparing a little bit something similar to Nabla to make it open for the developers to try it. So I will also try to do something similar with the TensorFlow. So maybe it will be possible in the next SDK release, but I'm not sure.
Okay. Another one here. Hello, a question would it be? What would it be? What would be the major advantages compared to other brands? For example, commercial products. They could not find the information about how to buy the chip. Is it available for selling?
If it's high volume, then
Okay.
we support that. Otherwise, now we are focusing on the kit. And what was the first part of the question?
What are the major advantages compared to other brands? Example for commercial product.
So what we have is, if you look at the capabilities of Spresense, high resolution audio capability of Spresense is not comparable to others out there. And also we have some, the GPS is available, the camera interface, and the best of all is low power, because you're targeting some devices that you put it somewhere, you don't want to plug it in the wall. The low power and then the 6 cores that you have, it gives you the capability to run applications at the edge. So if you're targeting those kind of applications, Spresense will be something that you benefit from these features.
Okay. I did get a couple more questions offline as well. I think you might have touched on this already, Armagon, but it asks, can I train my model on Spresense?
Yes. So Cammy,
Thank
do
you.
you
Yeah.
want? Yeah, I think we touched on that. But Cammy, do you want to add anything?
I mean, yes, so you cannot train your model as presence. I mean,
Oh, sorry, yes.
what you need to do is to train your model on your PC or in the cloud and then deploy this on this present, and then you can run the model on this
That's
present.
for any microcontroller. Usually you build your model and then you deploy it to the device. So that is the norm, yes.
Okay, another question has come in on the chat here. It's what kind of camera interfaces do you support and what is the image resolution?
Yeah, so I have actually the information here. Let me show you. So this is our camera spec. Do you see my page? So if you go to our the spec for Spresense, you can find this. But you ask about the interface. It's a CMOS 8-bit parallel. Did I answer all of the question? It was, yeah.
Yeah, I think you. And what is the image resolution? That was the other part to the question.
So the size, basically, this is the number of effective pixel that you can get.
Okay.
Yes.
Just a couple more here. Can I use the data from sensors other than the audio and camera as an input into my neural network? This is a great question. So would either of you guys want to choose when I answer this one?
Yes, Cameron, go ahead.
Yes, so you can connect any sensor that can be connected to this presence and use its data as an input for your neural network. I mean, there's no problem with this.
Okay. I think another one has popped in again is, okay, so do the examples make us use of all the 6 cores? I can't understand this question. Can you retype it again so we can actually answer it? I'll come back to it, but I do have another one. It says, does Presence uses CMSIS-NN libraries?
Yes, it is using CMSS and libraries, so it's make it even running your model even faster.
Okay, perfect. I still want to come back to that question. So if the person who's typed it can retype it again, then that will be good. And then I have another one here. Is there a separate format for the TensorFlow Lite micro models?
Yeah, so I can also answer this. I mean, there's no any separate format for the TensorFlow Lite micro. I mean, TensorFlow Lite micro is using the same format as TensorFlow Lite. So if you will convert your model from TensorFlow format to TensorFlow Lite, you can also use this for the TensorFlow Lite micro.
Okay. And another one came in again. What's the recording resolution on the camera? I think you touched on that, Armagon.
Yes, but I told you we have a new camera too. So that is going to replace the current one. So stay tuned and check our, you can subscribe actually to our newsletter for getting all of this new information coming out regarding our new boards. So if you go to our website and sign up for the newsletter, you will get the new information and updates for the new camera. Yes.
Perfect. So the other person just rewrote the question. It says, does the ML interface on Spresense make use of all the 6 cores, or is it just running on one core?
Yes, so currently for the TensorFlow, it's only using one core, the main core. I mean, the next step is to make it running on some other subcores. And the last step is to make it, to enable it to run this on all the cores. But currently, it only supports running the TensorFlow on the main core, so on the application core.
Okay. And then another follow-up to that specific question was, could you please mention examples that requires the use of 6 cores? What apps do you have in mind?
I mean, the 6 cores you can, for example, use currently for the Nabla, because the Nabla supports running AI using 6 cores. So thanks to this, you can do interface to your neural network much faster than using only one core. So this can be one of use cases.
We have an example for DNNRT that you can use all 6 cores, right?
Yes, exactly. This is
if you can share that link on the chat, then they can take a look. We have a lot of examples for DNNRT. That is the library supported by Spresense before TensorFlow. So you can get a lot of ideas from that. Also, if you go to our AI, this one that I mentioned. So if you go to this webinar, Spresense and AI, you will get a very good understanding of the DNNRT and examples, and how you can run AI on Spresense.
Okay, so I think that is it for our questions today. Actually, I lied. Another one's here. Did you try SSD kind of models like SSD Lite? If so, what is the inference speed?
If you want to find this kind of information, I highly recommend you to use Edge Impulse. You can put Spresense together as a kit, and then you can run a specific application, and you can get a lot of information as far as the power, or if, how long does it take, this kind of information. I suggest you to use the Edge Impulse. Unless, Camille, do you have any numbers regarding this from the previous examples that you have ran?
No, I don't have any specific numbers.
Yeah, go use the Edge Impulse. Edge Impulse is very, this is the link for Spresense. And then if you just wanted to prototype something really fast and see if this is the suitable board, if this is giving you the performance that you expect, or this kind of data, you can use the tool, and you don't need to be expert in AI. If you are, good for you. Otherwise, this is going to help you in few minutes to do that. We have actually a video, like 5, 6, 7 minutes video that maybe I can bring it up, that you can use, and you can maybe go to the Spresense. Let me just bring it up maybe. So if you guys keep talking, let me see if I can find this for you. You can just learn how to start with the Edge Impulse. And I think that's a good way to build your applications. My computer is a little bit slow, I think, because of the stuff. Okay, so here, guys, when I say go to our news and webinars, this is the link. You can go here. This is some training with the Edge Impulse. Also, you can find other videos that in just few minutes you can learn. This one is the long one. But you can go to our YouTube also and just go through these webinars also. But for the Edge Impulse, I suggest you to go to here and learn how to start with Edge Impulse. Okay.
Okay. So if there aren't any other questions, I'm going to do a quick wrap up here. Do want to thank you guys once again for your questions, really, really insightful questions. If you have any other ones, please send them to us and we'll answer them for you. As a goodwill gesture this week, we are offering you guys 10% off all of our Spresense boards to everyone who's attended today. The discount codes will be sent to you in the package in the next couple of days, so look out for that and proceed in ordering. And just to reiterate, we will send you the slide decks, the links, the on-demand version of the webinar, and all the discounts codes to you in a few days. As I've been stressing for the last year or so, please do follow Framos and Sony's Presence on LinkedIn, Instagram, Twitter for more company information, product launches, webinars, virtual events, just about everything. And also do go to the Sony developer website to basically get the information you need. There's the forum there as well. Please use those. And in the event that you need to purchase, go to the web shop and we'll have stock ready for you to purchase. So thank you so much again. We'll wrap up this time and I will see you and we'll see you next year. Thank you so much. Bye-bye, guys.
Thank you. Bye.